Fellow grade 12s, it's a beautiful Sunday today, and of course, we'll be revising grade 12 mathematics. If you're new here on Student Tools, please note that every Sunday we do some grade 12 mathematics revision for your benefit as a learner. So, if this is something that you are interested in, I would recommend that you subscribe so that you don't miss any of our Sunday video revision. Here on Student Tools, we also offer private tutorial sessions in two categories. So it's either you join a group tutorial session or a one-to-one person tutorial session. If there's something that you would also like, please simply click on the pop-up at the top right-hand corner of your screen or use the link in the description to join our Student Tools family. All right, so what are we doing today? Today we will be revising mathematics September 2022 trial exam paper 1. For part 1, we'll be doing algebra, which includes solving for x and simultaneous equations, number patterns and series, functions. To be specific, we'll be doing a hyperbola. All right, so let's dive into question 1. Question 1, we have 1.1, and 1.1 we are given an instruction whereby we are supposed to solve for x. And for the first one, we have an expression, a quadratic expression with a 1.1.1. And with that quadratic expression, we have x squared plus 4x minus 21 equal 0. So how are we going to solve for x in this case? On Student Tools, we have a video showing the top 3 ways of solving quadratic expressions. You can check out that video right now by clicking on the top right hand corner of your screen right now and see the top 3 ways of solving quadratic expressions. But right now we will use one of those methods, and this time I chose that we use the method which is called factorizing. So we will factorize here and end up solving for x. So to factorize this quadratic expression, we have 2 brackets which will be equal to 0. And here we will have an x, also here an x. And then for the other part, we have to find factors of 21. So factors of 21, we have 1 and 21. We also have 3 and 7. And those are the factors of 21. So with those factors of 21, they have to give us an answer of minus or negative 21 when multiplied, but also give us an answer of a positive 4, which is the coefficient of x in this case. When we add them together, they have to give us this positive 4. So what are those 2 factors that we can use? I think we can use this one, but the 3 has to be negative. This pair, the 3 and the 7, we can use that pair, but the 3 has to be negative. So with minus 3 and a positive 7, we have factorized this expression. So what's the next step? The next step is we have x minus 3. We have x minus 3 and have it equal to 0, or x plus 7 equal to 0 as well, and then we make x the subject with each of these expressions. So this side we have x minus 3, we have to make it the subject, x the subject. We will take the minus 3 from the left hand side to the right hand side, so we'll do that by adding 3 and also add 3 on the right hand side. So this will be a 0. X will be equal to a 0 plus 3, so that is a 3. X is equal to 3. And this side we have an x plus 7. We have to make x the subject. We will do that by taking the positive 7 from the left hand side to the right hand side. We'll do that by subtracting the 7 on the left and also subtract on the right hand side as well. This will be a 0. X will be equal to a 0 minus 7, that is a negative 7. So in this expression, when we solve for x, x will be equal to 3, or x is equal to a negative 7. And that is just how we solve for x in 1.1.1. Now let us move on to 1.1.2. 1.1.2, we are still solving for x, and we have another expression. We have x, open bracket, 2x minus a7, close bracket, equal to a3. Right, so we have this expression, and we're still solving for x. All right, let us expand this expression so that we can properly solve for x. So to expand this, we have x multiplied by 2x, that is a 2x squared. X multiplied by a negative 7 or a minus 7, that is minus 7x equal to a positive 3. And now we have this. Let us take the positive 3 from the right hand side to the left hand side. So we will do that by subtracting 3 over here, and also subtract 3 on the left hand side of the equal sign. So now we have 2x squared minus 7x minus 3 equal to a 3 minus 3, that is a 0. So to solve for x in this case, the next step would be to factorize this. So to factorize a quadratic expression like this one, we have to multiply the coefficient of x squared and the constant, so that we can get which factors we can use to factorize. So 2 multiplied by a negative 3, that is a negative 6. So now we have a negative 6. Let us find the factors of negative 6. Negative 6, we have 1 and 6 as a factor, and we have 2 and 3 as a pair of factors. So we only have these factors. Now with these factors we have to pick a pair which, when multiplied, it will give us an answer of negative 6, but when we add that pair, it has to give us an answer of negative 7. But similarly, there is no factor or a pair of factors that we can use that can give us an answer of negative 6 and at the same time give us an answer of negative 7 when we add that pair of factors. So that means this expression cannot be factorized. So when we cannot factorize an expression, we use the quadratic formula. So the quadratic formula, we have x equal to a minus b plus or minus the square root of b squared minus 4ac over 2a. Alright, now we have the quadratic formula, so we have to substitute into the formula to get the x values. And a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So now let us substitute into the formula so that we can get the values of x. X is equal to a minus b. Minus b, we have a 7, so we'll have a minus, and instead of b we will have a minus 7, plus or minus the square root of b squared, so that means minus 7 squared minus 4a. We have the coefficient of x squared, that is a 2, and we have c. C is the constant, and that is the negative 3. All this is over 2a. So for a, we have the coefficient of x squared, that is a 2. All right, let's write everything this side. So now we have x equal to a minus negative 7. That means it's a positive. So we have a positive 7 plus or minus the square root of negative 7 squared. That is a 49. Minus 4 multiplied by 2, that is an 8. And 8 multiplied by negative 3, that's going to give us a negative 24. So all this is over. 2 multiplied by 2, that is a 4. And then we have x equal to a plus or a positive 7 minus plus or minus the square root of 49 minus negative 24. So 49 plus 24, that is a 73. All this is over 4. So x is equal to, now let us punch this in our calculators so that we can get these values. Alright, so when we punch this on our calculator, we have a positive 7. For the first part, we will have the plus the square root of 73. All this is over 4. So what's the answer? And let's do that. We have a positive 3.886. So to 2 decimal places, that is a 3.89. So x, for the first part of x, we'll have a 3.89. And for the second part of x is equal to, we'll use the minus. Minus. So what's the answer? A negative 0.386. To 2 decimal places, that is a negative 0.8, negative 0.39. So x is equal to a negative 0.39. And that is just how we solve for x in this case. X is equal to a 3.89 or x is equal to a negative 0.39. And remember, we couldn't factorize this expression, so we used the quadratic formula to come up with the values of x. And now we have this. So remember, guys, when you cannot factorize an expression, always remember to use the quadratic formula. All right, next we have 1.1.3. 1.1.3, we are still solving for x. So we have an inequality. This is what we have. 2x plus 3 multiplied by x plus 1 less than a 6. So we're supposed to solve for x in this case. So to solve for x here, we will have to expand these brackets. To expand this, we will multiply 2x and x. There will be a 2x squared. 2x multiplied by a 1, that will be a plus 2x. And then 3 multiplied by an x, that will be a plus 3x. 3 multiplied by a 1, that will be a plus 3. All this is less than a 6. So 2x squared plus 2x plus 3x. So these are like terms, so we can add them. So 2x plus 3x, that will be a 5x plus 3 less than a 6. Because we want everything on the left hand side, so that means we will subtract 6 here such that will be less than a 0. So 2x squared plus 5x plus 3 minus 6. So this will be a minus 3 less than a 0. Okay, so now we have this. To solve for x here, we would have to factorize. So when we factorize an expression like this one, we multiply the coefficient of x squared and the constant. So when we multiply that, we will multiply 2 and minus 3. So that means it's a negative 6. And then we find the factors of 6. We have 1 and 6. We also have 2 and 3. But then we have to pick two factors which when multiplied, they will give us an answer of negative 6 and also give us an answer of a positive 5 when we add those two factors together. So which pair can we use? We can use 1 and 6, but 1 has to be negative. Why? Because when we multiply negative 1 and 6, we get a negative 6. Also, when you add negative 1 and 6, that will be a positive 5, which is the coefficient of x. So we will use these two factors to factorize, but we will do it a little bit different from the way we used to. So here we'll start with the 2x squared, and then we use this factor. We'll distribute negative 1 and 6 here to come out with 5x. So we will have minus x plus 6 here, 6x. So this is actually 5x. It's just that we distributed these two factors. And then we bring the minus 3. This is less than 0. And then here, the next step is to factorize this by grouping. We'll group the first two and the last two. So for the first two, we'll factor out, we'll find the common factor. Common factor is x. So we'll factor out x, and then we open our bracket. To get 2x squared, we will have to multiply x with a 2x. And then we have minus x. To get minus x, we'll have to multiply x with a minus 1. We close the bracket because we group the first two and the second group is the last two. So here with the last two terms, we have 3 as the common factor. So we'll factor it out and then we open our brackets. So to get 6x, we'll have to multiply 3 with a 2x. And to get negative 3, we'll have to multiply the positive x with a minus 1. So we close this bracket and all this is less than 0. So now that we have this, the final stage of factorizing this is to use our two brackets. Again, all this is less than 0. So within the first bracket, we'll write whatever we factored out here. That will be x plus 3, this one and this one. And then we have this 2x minus 1, which was also on the other bracket. So we'll write that 2x minus 1 on the next bracket. So this is how we factorize this. So if we had an equal sign here, not the inequality sign, we would say x plus 3, which is this one, equal to a 0, or 2x minus 1 is equal to a 0. So, and then make x the subject. So here when we make x the subject, x will be equal to a minus 3. And then here when we make x the subject, x will be equal to a positive 1 over 2. So those would have been our answers. But then we do not have an equal sign. We have an inequality sign, which is less than. So how are we going to solve for x if we have such? Let us look at this as a parabola. Say we have this parabola. It looks like this one. And we have these x-intercepts over here and over here. So with this parabola, this would have been our x is equal to negative 3. And here x will be 1 over 2. So with this statement, it says x plus 3 multiplied by 2x minus 1 less than 0. So that means with this expression, we want the x values of this graph, whereby this graph is less than 0. So it's this part where this graph is less than 0. So we want the x values where the graph is less than 0. So to answer that, that would be when x is greater than negative 3. but that x should be less than 1 over 2. So this is where the graph is less than 0, this graph. And that is just how we solve for x, or we solve this statement by giving out the values of x whereby this graph is less than x. And that is just how we do it. Let us proceed to the next question. 1.1.4, we are still solving for x. So we have this expression 2 root x plus x equal a3. So we have this expression, right? To do that, let's first take x from the left hand side to the right hand side. So we'll do that by subtracting x here and also subtract x on the right hand side. So this will be 0, and here we'll be left with a 2 root x equal to a 3 minus x. Yeah, so we have a square root here. So the only way to remove a square root is to square this. So whatever we do on the left hand side, we also have to do it on the right hand side. So we will square it as well. So when we square this, we will have 4x because the square removes the root. So all this is equal to 3 minus x squared. So that means we have 3 minus x multiplied by 3 minus x. So 4x equal to a 3 multiplied by a 3, that's a 9. 3 multiplied by a minus x, that is a minus 3x. Minus x multiplied by 3, that is a minus 3x. Minus x multiplied by minus x, that is a positive, because we are multiplying a minus and a minus, x squared. So now we have that 4x is equal to a 9 minus 3x minus 3x, that is a minus 6x plus x squared. Now that we have this, let us take the 4x from the left hand side to the right hand side. So we will do that by subtracting 4x and also subtract 4x this side as well. So this side we will have a 0. All this is equal to, alright, I'd like us to rearrange this and start with the x squared. We'll take it with its sign. So we have a positive x squared, so that means it will be x squared. And then we have 6x minus 6x minus 4x. So that means that's a minus 10x plus the 9. Right now we have this quadratic expression. So to solve this, we will factorize. So to factorize this, we will have our 2 brackets and they are equal to 0. Here we have an x and also here we have an x. So here we will have to find the factors of a positive 9, which when multiplied they will give us a positive 9, but when we add them together we have to get an answer of negative 10, which is the coefficient of x. So factors of 9, we have 1 and 9. We have 3 and of course 3 when we have a pair. So which of these can we use? Which pair can we use? We can use this pair, but 1 has to be negative and 9 has to be negative. Why? Because when you multiply negative 1 and negative 9, you get an answer of positive 9. But also when you add negative 1 and negative 9, you get an answer of negative 10. So that means we can use that pair. So here we will have a minus 1 and here we will have minus 9. So that is just how we factorize this part. So when we have this, we can say x minus 1 is equal to 0, or x minus 9 is equal to a 0. So for this, we have to make x the subject. So when we make x the subject here, x will be equal to a positive 1. And here, when we make x the subject, x will be equal to a positive 9. So x is equal to a positive 1 or x is equal to a positive 9. Because we are working with square roots, I think it's wise to check if our answers are correct. So let us first check with the positive 1. I'll punch that in our calculators. We'll check using the first part of the expression, which was 2 root x plus x will be equal to a 3. Let's check and substitute with the positive 1 here for the values of x. Right, so we have 2 root x. So for x we will substitute with the 1, and then we have plus x, which means we are still substituting with the 1. Let us see if we're going to get the positive 3. So we are getting positive 3 here. So that means the 1 is correct. And what about the 9? Let us substitute with the 9. So let us start here. We'll delete the 1 and add the 9. And also here, delete the 1, we add the 9. So is that equal to 3? No, it's equal to 15. So that means x is not equal to 9. X is only equal to a positive 1. And that is just how we solve for x in this case. Next is 1.2. 1.2, we are solving simultaneously for x and y. Right, so we will have two equations here and we're supposed to solve them simultaneously. So this is getting more interesting. Okay, guys and girls, let us write down our two equations so that we can solve them simultaneously. So for the first equation, we have 2y plus x plus a 3 equal to a 0. And then for the second one, we have x squared plus y squared plus 2xy equal to a positive 1. So those are our two equations. All right, we have several ways we can use to solve equations simultaneously, but in this case, a substitution method is the best way we can use to solve these two equations simultaneously. So to use the substitution method, let us first manipulate the first equation so that it will be easy for us to substitute and solve for x and y. So how are we going to manipulate this one? We will make x the subject. So when we make x the subject, that means we will subtract 2y here and also subtract 2y over that side. Also subtract 3 here. Subtract 3 on the right hand side as well, such that x would be equal to the 0 minus 2y, that will be a minus 2y and a minus 3. So now we have x equal to a minus 2y minus 3. So now on the second equation, instead of using x, we will use minus 2y minus 3. That is the substituting part of this process of solving equations simultaneously. Alright, now let us start. We have x squared. So instead of x squared, we will have this minus 2y minus 3 and have it squared. So minus 2y minus 3. It is squared. And then we bring the plus y squared down plus 2xy. So you know that instead of x, we will use minus 2y minus 3. So 2 multiplied by minus 2y y minus 3. Close bracket, and then we also multiply with the y. All this is equal to a positive 1. Now we have minus 2y minus 3 squared. So that means we have two brackets here. We have minus 2y minus 3. Also minus 2y minus 3 because it's squared. And then we have plus y squared. So here we have 2 multiplied by y multiplied by minus 2y. That is a 2y. Let's write it down over there. We have 2y multiplied by a minus 2y. So what is that? That is a minus 4y squared. And then next we have 2y multiplied by 3. So 2y multiplied by a minus 3. So what is that? That is a minus 6y. All this is equal to 1. But let's take the positive 1 from the right hand side to the left hand side. So we'll do that by subtracting 1 and also subtract 1 here, such that this will be equal to a 0. So from this we will need to expand these brackets. So to expand these brackets, we have minus 2y multiplied by minus 2y. Because we are multiplying a negative and a negative, it means we are getting a positive. So it will be a positive 4y squared. Also we have minus 2y or a negative 2y multiplied by 3. That's going to be a positive 6y. Now we have minus 3 multiplied by a minus 2y. That is again a positive 6y. And then we have minus 3 multiplied by a minus 3. That is a positive 9. And then we have y squared minus 4y squared. That is a minus 3y squared. So now we have that. Then we bring down this minus 6y minus 1 equal to a 0. Okay, next step is to find and sort these like terms. So we have these like terms. We have 4y squared minus 3y squared. That gives us a y squared. And then next we have these like terms. We have 6y, and minus 6y. So that gives us a positive 6y. And then we have these like terms, 9 and 1. So we have a positive 9 minus 1. That gives us a positive 8. All this is equal to a 0. Alright, now we have y squared plus 6y plus 8 equal to a 0. So now when we are on this step, we can now factorize and get the values of y. So to factorize this, we will have our two brackets and have them equal to a 0. Let's remove this so that we can use the space. And now we have to find the factors of 8. So factors of 8, we have 1 and 8. We have 2 and 4. So we have to pick a pair here, which when multiplied, it will give us a positive 8. But with that pair, it has to give us a positive 6, which is the coefficient of y when we add those two factors in that pair. So which pair can we use? We can use this pair. Why? Because when you multiply 2 and 4, you get a positive 8. But also when you add 2 and 4, that's a positive 6. So here we will have our y, and here we have the two factors, the plus 2 and the plus 4. So from here we can say y plus 2 is equal to 0, or y plus 4 is equal to a 0, which further means y is equal to a negative 2, or y is equal to a negative 4. So now we have the two y values. Now let us find the two values of x. So to find the x values, we will use the first equation, which we manipulated to x equal to a minus 2y minus 3. So for the first part, we will use y is equal to a negative 2. So x will be equal to a minus 2y. Instead of y, we will use minus 2 minus 3. So x will be equal to a minus 2 multiplied by a minus 2, that is a positive 4. And then we subtract the 3. So that means x is equal to a 1. And then again we have to find the value of x when y is equal to a negative 4. So x is equal to a minus 2y minus 3. So x is equal to a minus 2y. Instead of y, we will use the minus 4. Close bracket, minus 3. X is equal to negative 2 multiplied by a negative 4. That is a positive 8 minus 3. So x is equal to a 8. And 8 minus 3, that's a positive 5. So what does that mean? It means when x is equal to 1, y is equal to a negative 2. When x is equal to a positive 5, y is equal to a minus 4. And that is just how we solve these equations simultaneously. Ladies and gentlemen, let's move on to the next question. 1.3, it is given that k to the power 1 over x is equal to 3, k to the power 1 over 4 is equal to 4, and k to the power 1 over w is equal to 12. Prove that w is equal to xy over x plus y. Right, so this is what is given to us. K to the power 1 over x is equal to a 3. And then k to the power 1 over a y is equal to a 4. And then lastly, k to the power 1 over w is equal to a 12. So in this case, we are supposed to prove this. Prove that w is equal to xy over x plus ay. So how are we going to prove this? So the one thing that we know is 3 multiplied by a 4 is equal to a 12. So how does that fit in? It means that k to the power 1 over x, which is equal to 3, multiplied by k to the power 1 over 4, which is equal to 4, is equal to k to the power 1 over w. Okay, now since we are working with exponents, k to the power 1 over x multiplied by k to the power 1 over y, we have to add the indices. It means k is k to the power 1 over x plus 1 over y is equal to k to the power 1 over w. So now that we have this, we have the same basis. It means we can drop them. 1 over x plus 1 over y is equal to 1 over w. Since we are proving w, we want to make w the subject. So how are we going to do that? Let us first get rid of the denominators. So how are we going to do that? So let us first multiply everything by a w. So we will multiply with a w here and also multiply this with a w. So this will cancel this, and this side, let us write it on the other side because we will no longer have some space. So w multiplied by a 1 over x, that is a w over x. And then w multiplied by a 1 over a y, that is a plus w over y equal to a positive 1. So now we have this x and y. So to get rid of this x and y, we have to multiply everything with a xy. So we will multiply this with xy, also this xy we're multiplying, and the other side we multiply with an xy as well. So this x will cancel this x, and this y will cancel this y, such that we are left with a w multiplied with a y. So we have w y plus a w x equal to a 1 multiplied by xy. So we have x y over here. And now we have this wy multiplied by wx equal to xy. So remember, we want to make w the subject. So we will factor out w here, and here we will have y plus x, close bracket, equal to x y. So to make w the subject, we'll divide by y plus x, and also the other side we divide by y plus x. So this will cancel this, such that w will be equal to xy over y plus x. So we have just proved that w is equal to xy over xy. So don't be scared by this. It's the same as this. Y plus x is just the same as x plus y because the signs are the same. So that's just how we prove whatever we are given here. Okay, guys and girls, let us proceed to the next question. Question 2, we have 2.1. 2.1 says that an arithmetic series has a common difference of 4. 3x minus 1 and 2x plus 8 are the fourth and the seventh terms of the series respectively. Alright, so we are told that we have an arithmetic series with a common difference of 4. And then we have 3x minus 1 and 2x plus 8 as the fourth and the seventh terms of the series respectively. So that means at term number 4 we have 3x minus 1. So here we have 3x minus 1. And at term number 7 we have 2x plus an 8. So we also have terms here and a term over there, term number 5, term number 6. So the other thing that we're told is that we have a common difference of 4. 4, 4. And 2.1.1 requires that we determine the value of x. So what is the value of x? So let us first fill in what is supposed to be on term number 5 and term number 6. So 3x minus 1 plus the 4, because we have a common difference of 4. So 3x minus 1 plus 4. So that is 3x negative 1 plus 4, that is a plus 3. So that means here we have 3x plus 3. And then again we still have a common difference of 4. 3x plus 3 plus the common difference, which is 4. So that is 3x, 3 plus 4, that is a 7, positive 7. So here we will have a 3x plus a 7. Now how do we get the value of x? So to get the value of x, we would use this. We will say 2x plus 8, this one, minus 3x plus 7 is equal to, the 3x plus 7 is this one. So that will be equal to a 3x plus 3 minus, I forgot to put the brackets here. So minus, we put the brackets, 3x minus 1. So you should understand why I say 2x plus 8 minus 3x plus 7 is equal to 3x plus 3 minus 3x minus 1. It's because we have this common difference. So here we have 2x plus 8 minus 3x minus 7 equal to 3x plus 3 minus 3x plus 1. So let us collect and sort the like terms. 2x minus 3x, that is a minus x. Positive 8 minus 7, that is a positive 1. All this is equal to a 3x minus 3x, that's a 0. So 3 plus 1, that's a 4. Okay, now so we are supposed to take the positive 1 from the left hand side to the right hand side. So we will do that by subtracting 1 here and also subtract 1 on the right hand side. So minus x will be equal to a 4 minus 1, that's a 3. So to make x the subject, we will divide by a negative 1 both sides, such that x will be equal to a negative 3. And that is just how we find the value of x on 2.1.1. X is equal to a negative 3. Let us move on to the next question, 2.1.2. Okay, now we have 2.1.2a says we should calculate the first term of the series. So how do we calculate the first term of the series? First, let us write down what we know. We know that we have a common difference of 4. We also know that x is equal to a negative 3. And we know that term number 4 is equal to a 3x minus 1. So if we were to find the exact value of term number 4, that will be equal to a 3 multiplied by the x is equal to a negative 3. So we will substitute with a negative 3 here. And then we bring the minus 1. So that will be equal to 3 multiplied by a negative 3. That is a minus 9. And then we bring the minus 1. So that is equal to a minus 10. Okay, now that we have this information, let us try and find the first term of the series. So we were told here that this is an arithmetic series. And with an arithmetic series, we have this formula. Tn is equal to a plus n minus 1 times d. So because we are trying to find the first term, we have to find the value of a. So to find the value of a, we will use term number 4. So term number 4 is equal to a plus n minus 1. So that means we will have 4 minus 1 here, multiplied by d. D is equal to a4. So term number 4 is actually equal to a negative 10. So let us put negative 10 here, equal to a plus 4 minus 1, that's a 3. So we will have a 3 here, multiplied by a positive 4. So negative 10 is equal to a plus 3 multiplied by a 4, that is a 12. So to make a the subject, we would have to take the positive 12 from the right hand side to the left hand side. So we will do that by subtracting 12 here and also subtract 12 over there. So that means a is equal to a minus 10 minus 12. So that is a minus 22. So the first term is equal to a negative 2. So T1 is equal to a negative 22. And it is just how we find the first term of this series. Alright, and then we have B, which says calculate the sum of the first 42 terms of the series. So now we know that A is equal to a negative 22. D is equal to a4. And since we want the sum of the first 42 terms of the series, n will be equal to a 42. Right? Now let us use our formula to find the sum of the first 42 terms of the series. So since it's an arithmetic series, we will use this formula, equal to n over 2 open bracket 2a plus n minus 1 close bracket multiplied by d with close bracket. So this is the formula that we are going to use to find the sum of the first 42 terms of this arithmetic series. So let us do that. So we want the sum of the 42 terms equal to 42 over 2. Open bracket, 2 multiplied by a is negative 22. Close bracket, plus n minus 1. So that's 42 minus 1. Close bracket, and then we multiply with the common difference, which is 4. Close bracket. So the sum of the 42 terms is equal to 42 divided by 2, that's a 21. Open bracket, 2 multiplied by a negative 22, that is a minus 44, plus 42 minus 1, that is a 41, multiplied by a 4. So we close this bracket. The sum of the 42 terms is equal to 21 open bracket minus 44 plus 41 multiplied by a 4, that is a positive 164. So we close this bracket, and then we have this sum of the 42 terms is 21 multiplied by negative 44 plus 164, that is a 120. So that means the sum of the 42 terms is equal to a 21 multiplied by a 21 multiplied by 120. When you punch it on your calculator, you will get a 2,520. So that's the sum of the first 42 terms of the series. And that is just how we calculate that. So next is 2.2. Alright, so now we are on 2.2. 2.2 says the first term of a quadratic number pattern is 61. Alright, let's write it down. We have term number 1 equal to a 61. So what's the next term? Okay, we're not given. And term number k is equal to 4k minus 26 forms the first differences of the quadratic number pattern. Alright, so we're given this other formula, which is term number k equal to 4k minus 26. So we're given this general term, and we're told that this general term forms the first differences of the quadratic number pattern. So here we're given this quadratic pattern, which has the first term as 61. So we do not know the next one or the next terms after 61. But then we are told that this general term gives the first differences here, or forms the first differences. So for the first difference of the first differences, let us try and find what value do we get. So that means we will have term number 1 will be equal to 4 multiplied by 1, because we want the first difference of the first differences. So multiplied by 1 minus 26. So this will be equal to 4 multiplied by 1, that is a 4, minus 26. So this is equal to a minus 22. So that means the first difference is minus 22, the first difference of the first differences. And then for this one, we'll use the same formula. So term number 2 will be equal to 4 multiplied by 2 minus 26. So this will be equal to 4 multiplied by 2, that is an 8, minus 26. So what is an 8 minus 826? That is a minus 18. And then for the third one, we have term number 3 equal to a 4 multiplied by a 3 minus 26. And 4 multiplied by 3, that is a 12. 12 minus 26, that is equal to a minus 14. So here we will have a minus 14. So these are the first differences. So to get to the next term, we would have to add 61 and minus 22, or the negative 22. So what is 61 plus negative 22? 61 plus negative 22 is 839. So we have the second term. So here on the question, we were told that we should find the second and the third term of the quadratic number pattern. And then what's the third term? We already have the second term. So that means we will have to add 39 and negative 38. So what is 39 plus negative 38, negative 18? That is equal to a 21. So that is just how we find the second and the third term. The second term is equal to 39. We can put it here, write it as T2 equal to 39. And then term number 3 is equal to a 21. And that is just how we do it, ladies and gentlemen. Let us move on to 2.2.2. 2.2.2 says if the nth term of the quadratic number pattern is given by the nth term equal to 2n squared minus 28n plus 87. Calculate the value of the smallest term. All right, so here we're given the nth term, and we're supposed to calculate the value of the smallest term. So how are we going to do that? The nth term is equal to n squared minus 28n plus 87. Right, so here, this is a quadratic number pattern, and this is the nth term. If we were to treat this one as a parabola, let's say maybe it was a parabola, one that looks like this, because a is actually greater than 0. A is the coefficient of n squared, so it will be smiling. So to find the lowest term, or the smallest term, or the smallest value in this term, it will be at the turning point if we're treating it as a parabola. So at the turning point, that's where we are going to find the smallest value of the pattern or sequence. So with parabolas, how do we usually find the turning point? We use this formula. We usually use x is equal to minus b over 2a, but here we're dealing with sequences, so we will say n is equal to a minus b over 2a. We want to find the value of the smallest term. So to do this, we will use this formula. So a is the coefficient of n squared, and then b is the coefficient of n. This is the constant. So here n will be equal to a minus b. b is equal to a negative 28. All this is over 2a. a is equal to 2 because it's the coefficient of n squared. So n will be equal to negative multiplied by a negative 28. That is a positive 28 over 2 multiplied by 2, that is a 4. So n is equal to a 28 divided by 4. What is a 28 divided by 4? That is a 7. So what is this telling us? It's telling us that we get the smallest value when n is equal to a 7. So now let us find the smallest term, which is actually term number 7. So term number 7 is equal to 2 multiplied by n squared, so we will substitute with the 7. So 7 is squared here, minus 28n, we substitute with a 7, plus 87. So term number 7, which is the smallest term, 2 multiplied by 7 squared, that is a 49, minus 28 multiplied, that is a 196, plus 87. Term number 7 is equal to 2 multiplied by 49, that is a 98, minus 196 plus 87. So what is term number 7? So that is 98 minus 196 plus 87. I will punch that on my calculator. Alright, so that's a negative 11. So that means the smallest term in this sequence is negative 11. And that is just how we calculate the value of the smallest term in this question, ladies and gentlemen. Let us move on to 2.2.3. All right, 2.2.3 says a constant k is added to the nth term such that all the terms of the quadratic number pattern become positive. Determine the values of k. All right, so here we are told that a constant k is added to this nth term such that all the terms in this pattern become positive. So one thing that we know is that the smallest term is negative 11, and that's the one which is the smallest. So if we were to add anything on this nth term, it should be greater than this 11 to make 11 at least a positive one, or a positive number. So that means k should be greater than an 11. So at least the smallest term would at least be 1 or 2. If let's say maybe k is equal to a 12. When you add negative 11 and a 12, the smallest term will be a 1. And then when maybe, let's say maybe k is equal to a 13, then when you add negative 11 and a 13, then that smallest term will be equal to a 2. Again, if we were to say maybe k is equal to a 14, then the smallest term will be equal to a 3. And that is just how we determine the values of k. K should be greater than 11. Yeah, we're gauging that using the smallest term. Right, now let us move on to question 3. All right, now we are on question 3. Question 3, we have 3.1, which says that we are given that p is equal to 0.0,7 with a dot, which means it actually recurs, and that is equal to a 0.777777. Yeah. So 3.1.1, write down p as a geometric series. Okay, so we have this p equal to a 0.7, which shows it recurs with that dot. So that means if it recurs, it means it's a 0.7777, yeah, continuously. So 3.1.1 says we should write down p as a geometric series. So if we were to write this as a geometric series, we would have a 0.7 plus, because it's a series, it's not a sequence, we don't use the commas. So the next one will be 0.07 plus 0.007 continuously. So that means we're actually gonna add another 0.0007. So that is just how we write this as a geometric series. Let us move on to 3.1.2. 3.1.2 says we should represent the series in sigma notation. Okay, so let us try and represent this in sigma notation. But first, let us determine the value of a, which is the first term. It's 0.7, and we have to determine the ratio, which is equal to a 0.07 over 0.7. So what is that? I will just punch that on my calculator and see what I come up with. All right, my calculator gives me a 1/10. So we have that ratio. So all right, so I'm actually gathering this information because I want to get the nth term of this geometric series. So to find the nth term of the geometric series, we have this formula. The nth term is equal to a r to the power n minus 1. So the nth term is equal to a 0.7, we put it in brackets, and then r is equal to a 1/10. That is to the power n minus 1. So that is just how we find the nth term. Now the instruction was to represent this in sigma notation. So let us do that. All right, so P is equal to, let us write our sigma sign, and we have this general term that is 0, 7 multiplied by 1 over 10 to the power n minus 1, starting from n is equal to a1. And then how many terms do we have in the series? That is infinite. So that is just how we represent this in sigma notation. Okay, guys and girls, let us move on to 3.1.3. 3.1.3, determine the sum to infinity of the geometric series as a proper fraction. Right, so here we are supposed to determine the sum to infinity of this geometric series. Let us write again what we know. We know that a is equal to a 0 comma 7, and we know that r is equal to a 1 over 10 or a 0.1. And what are we actually looking for? We want to determine the sum to infinity. So that means n is equal to infinity. So we have a formula to determine the sum to infinity. That is this formula, the sum to infinity equal to a over 1 minus r. And what you should know is that in order to calculate the sum to infinity of a series, r should be greater than -1 but less than 1. That is something that you should know. And here in our case, we have r as 0.1. So we are good. So let us calculate the sum to infinity in our series. We have this. A is equal to a 0.7. All this is over 1 minus 0.1. So what's the sum to infinity? I'll just punch that on my calculator. You also do the same. My calculator gives me a 7 over 9. And that is just how we calculate the sum to infinity of this series. Okay, let us proceed to the next question. Now we are on 3.2. 3.2 says, in a geometric series, the sum of the 9th and the 10th term is 6 times the 8th term. Determine the values of r, the common ratio of the sequence. Alright, so here we're told about a geometric sequence. We are told about the 8th, 9th, and 10th term of the sequence. And it's a geometric sequence. So we have term number 8, term number 9, and also term number 10. So here we are told that it's a geometric sequence. So with geometric sequences, we have a formula of the nth term equal to a r to the power n minus 1. So if we were to find term number 8, we would say term number 8 will be equal to a r to the power n minus 1. We substitute n with the 8, so it's 8 minus 1. So that means term number 8 will be equal to ar to the power 7. So let us write it here. Term number 8 is equal to ar to the power 7. So what does that mean? That means for term number 9, we will have ar to the power 8. And for term number 10, we will have ar to the power 9. And that's just how it is. So we want to determine the values of the common ratio in this case. So a statement that was given to us here is that the sum of the 9th and the 10th term is 6 times the 8th term. So let us say we have the 9th term, which is a r to the power 8. That's the 9th term. If we add the 10th term, which is equal to a r to the power 9, that will be equal to 6 times the 8th term. So that is 6 multiplied the 8th term, which is a r to the power 7. So because we want r here, let us try and factor out a r to the power 7 here. So we factored out that. Let's open a bracket. So to get a r to the power 8, we have to multiply a r to the power 7 by r. And then to get a r to the power 9, we have to multiply a r to the power 7 by n r to the power 2, or a r squared. So we close that bracket. That is equal to 6 a r to the power 7. We want to get rid of this a r to the power 7 here, so we will divide by a r to the power 7 here, and also divide by a r to the power 7 here. So this will cancel this, and this will cancel this, such that we will be left with r plus r squared equal to a 6. Alright, now let's do this. Let's rearrange this and start with the r squared. So here we have r squared plus r. I want us to take the positive 6 from the right hand side to the left hand side. So on the left hand side, 6 will be minus 6. So this will be equal to a 0. And now we want to factorize. Equal to 0. So r here, we have r here. And we want factors of 6, which when multiplied, they will give us an answer of negative 6, but also give us an answer of positive 1 when we add those two factors together. So we have factors of 6, we have 1 and 6, we have 2 and 3. So which pair can we use? I think we can use this pair, but this 2 has to be negative, because negative 2 multiplied by 3, that is a negative 6, but also negative 2 plus 3, that is a positive 1, which is the coefficient of r here. So we will use negative 2 and positive 3. So that means r minus 2 is equal to a 0, or r plus 3 is equal to a 0. So when we make r the subject here, with r minus 2 equal to 0, we have r equal to a positive 2. Or here, if we make r the subject, r will be equal to a negative 3. And that is just how we find the possible common ratio of this mysterious sequence. Okay, now let us move on to question 4. Question 4, we are doing functions. And here we have a statement which says, in the diagram below, the graph of a hyperbolic function. Okay, so here we are dealing with a hyperbola. F of x is equal to x plus k over x plus p, where k is a constant, is thrown. A and B are the x-intercept and y-intercept of f respectively. The vertical asymptote goes through the x-axis at 3. Right, so here we have this hyperbola function, and we have the x and y-intercept A here and B, and also we have the vertical asymptote which goes through at 3. We are not told about the horizontal asymptote. Right, so here we have a question below 4.1 which says write down the value of p. Right, so we have this function f of x equal to x plus k over x plus p. So 4.1 requires that we find this value of p. So how are we going to find the value of p? Okay, this is a little bit different from the typical hyperbolas we know. So to remind you, the hyperbolas we usually deal with, they have a formula which looks like this one: y equal to a over x plus p plus q. And where do we get the values of p and q? We get these values of p and q from the asymptotes. So for instance, the horizontal asymptote, which is y, and y would be equal to something, but here y is equal to q. And then for the vertical asymptote, which is x, x is equal to a minus p. And here we want the value of p. We know that the vertical asymptote is x equal to a 3. So we can use this value to find the value of p. So to find the value of p, we will substitute x with a 3. So that means 3 is equal to a minus p. And then we have to make p the subject. So we will do that by dividing by 1 both sides, and p will be equal to a negative 3. And that is just how we find the value of p. We are taking that from the vertical asymptote. Okay, let us proceed to 4.2. 4.2, determine the values of k. Alright, so here we have our function f of x equal to x plus k over x plus p. We found that the value of p is negative 3, so it will be x minus 3 over here. So question 4.2 requires that we find the value of k, this k. So how are we going to do that? We know that we have a coordinate that we can use here, a, which is 1, 0, which can help us get the value of k here in this case. So let us use a to find the value of k. So we'll make f of x equal to a 0. Why? Because y is equal to a 0. So f of x will also be equal to 0. So this is equal to x. So for x, we will substitute that with the 1. Because here x is equal to 1. So this will be 1 plus k over x minus 3. So that means it's 1 minus 3. And then we have 0 equal to 1 plus k over 1 minus 3. That is a negative 2. And then we get rid of this denominator. So we will do that by multiplying everything by a negative 2. So multiply by a negative 2 here as well. Although it doesn't change anything because negative 2 multiplied by a 0 is still a 0. But this will be cancelling this such that we will be left with 1 plus k. And then to make k the subject, because that's what we want, we will have to take the positive 1 from the right hand side to the left hand side. So we'll do that by subtracting 1 here and also subtract 1 on the left hand side, such that k will be equal to a negative 1. And that is just how we find the value of k. Okay, next question. So right here we have 4.3, and 4.3 says that we must calculate the coordinates of B. So coordinates of B is this one. So B is the y-intercept of the graph F. So how do we find the coordinates of B? One thing we know is that B is the y-intercept, so x is equal to 0. So using our function here, let us find the coordinates of B. So let us write down our function. F of x is equal to x minus 1, because k is equal to a negative 1. So x minus 1 over x minus 3. And then we use this information because we're dealing with a y-intercept. So we will make our x equal to a 0. So we want to find f of 0. So this will be equal to 0 minus 1. We'll substitute x with a 0 over 0 minus a 3. And then f of 0 will be equal to 0 minus 1, that's a negative 1, over 0 minus 3, that is a negative 3. So that means f of 0 is equal to a positive 1 over 3. Meaning the coordinates of B are, for x we have 0. And then the y value of this coordinate is 1 over 3. And that is just how we find the coordinates of B. 4.4. Determine the values of x for which x multiplied by f of x is less or equal to a 0. Right, so to do this, I want us to create a table to find these values. All right, now we have our table. To do this, here we will have an x, and here we will have y or f of x. So what are we actually looking for here? We are looking for the values of x for which x multiplied by f of x is less or equal to a 0. Let us start this from here, from the asymptote. X at the asymptote is equal to a 3. And then what's the y value or f of x? That is undefined. So that means we'll discard that. And then what about 2? X, when x is equal to 2, what is the y value? All right, let us write our function first. We have f of x equal to x minus 1 over x minus 3. And we want the f of 2. So f of 2 is equal to 2 minus 1 over 2 minus 3. This is equal to 2 minus 1, that is a 1, over 2 minus 3, that is a negative 1. So that means y will be equal to a negative 1. And what is x multiplied by f of x? That is equal to a negative 2, because it's 2 multiplied by a negative 1. So this is less than 0. And then we go to f of 1. When this graph is at 1, what is y or f of x? We have it here, it's the x-intercept. So that is 0. And then 1 multiplied by 0, that is equal to a 0. So we move on to x is equal to a 0. So what would be the value of y or f of x? That would be 1 over 3. We got that here when we were looking for the value of b. And then over here, what value do we get when we multiply x and f of x? So that is still a 0. And then we proceed to the negative side of this graph, which is negative 1. So what is f of negative 1? F of negative 1 will be equal to a negative 1 minus 1 over negative 1 minus 3. And that is equal to negative 1 minus 1, that is a minus 2 over negative 1 minus 3, that is a minus 4. So here we're getting a positive half. So here we'll have 1 over 2 as the y value, or f of x. And then what do we get when we multiply x and f of x? Negative 1 multiplied by negative half, that is a negative half. So now we go on to x is equal to a negative 2. We proceed to x to a negative 3. We want the y values, or f of x, of this. Let's remove this to find f of 2 and f of 3. So f of 2 will be equal to a negative 2 minus 1 over negative 2 minus 3. So this is equal to negative 2 minus 1, that's a negative 3, over negative 2 minus 3, that's a negative 5. Okay, so this is a positive 3 over 5. So here for f of x, or y value of f of negative 2, that is a positive 3 over 5. And then when we multiply negative 2 and the 3 over 5, which is x multiplied by f of x, we get a negative 6 over 5. And then next we want f of negative 3. F of negative 3, that will be equal to a negative 3 minus 1 over negative 3 minus 3. So this is equal to negative 3 minus 1, that is negative 4, over negative 3 minus 3, that's a negative 6. So this is equal to a 2 over 3. So that means our f of x is equal to a 2 over 3. And then what happens when we multiply x and f of x? Of this, we have negative 3 multiplied by 2 over 3. So we get a negative 6 over 3, which is actually equal to a negative 2. So already we're seeing this trend here. What we're looking for the values of x, whereby x multiplied by f of x is less or equal to 0. So from here, we're getting results which are less than 0. So what will be our first answer? So you must note that from when x is equal to 0, we're getting an answer of 0, and then going downwards on the negative side, on the negative side of x, we're getting results which are less than 0. So that means x should be less or equal to 0 for this statement to be true. And for this other part, so that means our statement or our answer should look like this. X should be greater than 0, but less than 3, because 3 is the asymptote. And this statement makes this x multiplied by f of x less or equal to 0 true. So it's these two statements. So these are the x values which make this statement possible or true. And that is just how we answer 4.4. 4.5, rewrite the equation of f in the form of f of x equal to a over x plus p plus q. So this is what I was talking about on 4.1. This is the typical hyperbola we are used to, which is f of x equal to a over x plus p plus q. And we know that we get the values of p and q from the asymptotes. So we have two asymptotes here. We have the horizontal, we have the vertical. And then how do we write them? So for the horizontal, we have y is equal to that. We are not given the horizontal asymptote, so we do not know it. So what about the vertical asymptote? We have x equal to a3. And then we also know that the horizontal asymptote is also equal to q. And also the vertical asymptote is also equal to the negative p. So as we were doing the previous questions, we got that our function is f of x equal to x minus 1 over x minus 3. So we want to change this to look like this. So how are we going to do that? We will do that by doing this. F of x will be equal to x minus 1. So we have x minus 1 here. Because we want to get rid of this, let us make this x minus 3 over x minus 3. And then here at the top, we add 2. We put some brackets over here. Here we haven't changed anything because x minus 3 plus 2 is still x minus 1. So we haven't changed anything. We just want to get rid of this such that we are left with one value of a. So this will be the same as f of x is equal to x minus 3 plus 2 over x minus 3 is the same as x minus 3 over x minus 3 plus 2 over x minus 3. So because this is x minus 3 and this is x minus 3, this will cancel each other such that here we will be left with a 1. So when we're taking it over the other side, we have f of x equal to 1 over 1, that is a 1, plus 2 over x minus 3. So we can write it like this if we want it to be arranged like this. So f of x will be equal to a 2 over x minus 3 plus 1. So now we have the value of a as 2 and we have the value of q as 1. So that means our q is actually equal to 1. And that means our horizontal asymptote is also equal to 1. So that is just how we rewrite this equation of f. It will end up looking like this, as f of x equal to 2 over x minus 3 plus 1. Alright, now we are done with question 4. Well, that marks the end of part 1 of this tutorial, and make sure you subscribe to the channel so that you don't miss part 2 when it has been uploaded. On part 2, we will be doing graphs, a parabola, and an exponential graph to be specific, financial mathematics, a bit of calculus. Also remember that we are here next week Sunday to do some math revision with you. And if you would like to get yourself a math tutor, make sure you check out the link in the description. Bye bye.